All right, welcome back. So today we've got a really fun and honestly a super rewarding goal. We're going to conquer the math behind the elasticity of demand. Now, if you've ever stared at a page full of Greek letters and economic equations and just felt the sudden urge to run for the hills, take a deep breath. It's going to be okay. We're going to unpack the percentage method step by step, taking what looks like this massive mathematical hurdle and turning it into a totally logical, easy to remember tool. Okay, let's dive right in. Our exact mission for this explainer is to answer one really crucial question. How do we take a plain English definition of consumer behavior and actually translate it into a simple, usable formula? Because, economics is all about measuring real human reactions, whether you're just trying to ace your next exam or you're out there figuring out how to price a brand new product. To measure those reactions accurately, we need a reliable equation. And the best part? The formula basically builds itself if you just follow the logic. Let me show you. But before we throw any complex math at the wall, let's just ground ourselves in the core human-readable definition. Our source material tells us that the percentage method, which, by the way, you might also hear called the ratio or proportionate method, measures price elasticity of demand simply as the ratio of the percentage change in quantity demanded to the percentage change in price. That is literally it. We are just comparing how much the amount people buy changes, as a percentage, against how much the price tag changed, also as a percentage. It's a super simple comparison. You've got your cause on the bottom and your effect on the top. Now, we got to translate those words into symbols. Think of this as, well, kind of like meeting the cast of characters for our equation. First up, we have the Greek letter delta, which just looks like a little triangle. In math, delta is just shorthand for change in. So delta Q, that's the change in quantity demanded. A plain old Q, on the other hand, stands for the original initial quantity demanded. It works the exact same way for price. Delta P is the change in price, and a plain P is your original price. By breaking it down like this, character by character, we completely remove all the confusion before we even start building the equation itself. So let's plug those characters into our definition. To find the percentage change, you just take the change, divide it by the original number, and multiply by 100, right? Since elasticity is the ratio of these two percentage changes, we get this somewhat intimidating raw equation. You've got the percentage change in quantity on top, so delta Q over Q times 100, and that whole thing is being divided by the percentage change in price on the bottom, delta P over P times 100. I know. Looking at a giant double fraction with brackets everywhere can cause a bit of stress. It looks incredibly messy. But watch what happens next. This is where algebra beautifully works in our favor. Notice those 100s? Because we're multiplying by 100 in both the very top part of our massive fraction and the bottom part, they perfectly cancel each other out. Boom, gone. Just like that, the formula starts to simplify itself. We can completely drop the 100s, and we're left with a much cleaner expression. Delta Q divided by Q, all divided by delta P divided by P. We have literally just eliminated half the clutter in one single step. Okay, let's move to the next logical step. We still have a fraction divided by a fraction, which is pretty annoying. But as you might remember from middle school math, dividing by a fraction is the exact same thing as multiplying by its reciprocal. In plain terms, we just take that bottom fraction, flip it completely upside down, and change the division sign to a multiplication sign. So delta Q over Q divided by delta P over P simply becomes delta Q over Q multiplied by P over delta P. Easy, right? And that brings us to our big ta-da moment. To make the formula as clean and intuitive as humanly possible, we just rearrange the multiplication a little bit so that like elements are grouped together. We put the changes, those deltas, together, and the original values together. So the absolute crucial takeaway here is this final, perfectly simplified equation. EP equals delta Q over delta P multiplied by P over Q. Look at that. You have successfully translated a dense paragraph of economic theory into a sleek, totally exam-ready formula. And remember, these algebraic symbols aren't just abstract, floating math concepts. They represent actual, real-world movements in the market. If you look at a relatively elastic demand curve, when the original price, P1, drops to P2, that vertical drop, that is your delta P. In this specific case, it's a 10% fall. And because of that price drop, the original quantity Q1 jumps to Q2. That horizontal expansion right there is your delta Q, a 20% increase. You can literally see the formula playing out visually. These mathematical ratios represent real consumers reacting to real price tags in real time. So, as we wrap up this explainer, I really want to leave you with a question to think about. The next time you see a price drop in a store, will it ever look the same to you? Probably not, right? Because now you actually know the mathematical secret behind the shift.
You've seen exactly how a complex idea distills all the way down into one elegant formula. You are officially equipped to tackle this math with total confidence on your exam. Keep analyzing, keep calculating, and I'll see you in the next explainer.